space travel sounds thrilling, right? What if you had to make tough decisions before you even launch? Like today, we are tackling a captivating problem about assembling the ultimate crew for a journey to the moon. If you could only take a handful of people with you, who would you choose and why? Join me as we break down the challenge, discover the secrets to planning a successful expedition into the stars. Alright, let's dive into understanding the HackerRank graph theory problem of journey to the moon. Imagine you're at an interstellar party with astronauts from various countries. Each country is represented as a node in a graph, and the friendship between astronauts from these countries are the connecting edges of these nodes. Our goal to find out how many pairs of astronauts can be found that are from different countries. Okay, now let's break down this. First off, we have a total of n astronauts and we are given p pairs of friendship. Each pair indicates that the two astronauts are from the same country. This means if we can identify the connected components in this graph, those group of astronauts that can reach each other through friendship, we can figure out how many astronauts belong to each country. Yes, things get interesting. When we identify this component, we can calculate how many astronauts are from each group. For example, if there are 5 astronauts in one country and 3 in another, we can't form a pair between them because astronauts are from the same country. So we have to consider all possible pairs of astronauts from different countries. To solve this, we are going to use DFS, depth first search, to explore our graph. DFS will help us traverse to the graph and mark which astronauts we have visited, allowing us to count the size of each connected components. Once we have the size of this component, we can calculate the total number of pair of astronauts, and subtract the pairs that can be formed within the same country. Let's think about the math for a second. The total number of ways to select 2 astronauts from n is given by combination formula. The formula gives us all possible pairs. But now we need to subtract the pairs that are within the same country. For each country, the size astronaut, the number of pairs is this. After calculating the pair within each country, we simply subtract that from our total pairs. This gives our answer to our problem, the number of astronaut pairs that comes from different countries. So to summarize our approach, first, build a graph from the astronaut friendship. Number 2, use DFS to find all connected components and their sizes. Number 3, calculate the total pair of astronauts. Number 4, subtract the pair that can be found within the same country. We'll create an adjacency list, perform DFS, and compute the combination of all which are foundational skills in coding interviews and competitive programming. If you found this insightful, make sure to hit that like button and subscribe for more coding challenges and solutions. Make sure to check out the source code in the description below. And don't go away yet. In our next videos, we are going to dive deeper into simplifying more advanced graph theories, including DFS, that is breadth first search. Trust me, you don't want to miss it. Until then, keep coding.